Good afternoon. All right. You are welcome to our lectures on pharmaceutical calculations, BD 253. And today we are entering a new topic, ratio, proportion, and variation. So we'll start from ratio. This particular topic, ratio and proportion, about 90% of whatever you are going to do in pharmaceutical calculations as a student or as a pharmacy technician is rooted in what? Ratio and proportion, especially proportion. So take this topic seriously. Up to 90% or more of calculations that you are going to do, even when you are working, either in community pharmacy or manufacturing outlets, has a lot to do with what? Proportion. By the time we start solving questions, you understand what I mean. A lot of topics in this course are rooted in what? Proportion. If you don't understand proportion, you have issues with these topics, with those topics. All right, now let's go to ratio. Let's go to ratio. That's what is called value of numbers. That's what they call absolute value, and that's what they call relative value. When you talk about absolute or terms of magnitude, absolute value or magnitude of a number, it talks about the magnitude of that number as it is. But when you talk about relative, you are comparing it to what? Another what? Number. So that's what ratio is all about. Ratio and common fractions are the same thing. The only difference is how they are presented. In the common fraction, you have the numerator, the denominator. You have the numerator, the fractional line, and the denominator. But in ratio, you have A is to B, first term and second term. If you see something like A is to B, A is the first term and B is the what? Second term. And if you want to express that same A is to B as a common fraction, it's simply A over what? B. They are the same thing. All the rules that apply in common fractions also apply in what? Ratio. They're the same thing. Same thing. I think I mentioned this when we are treating fractions, right? I told you that they're just talking about the same thing. Now, if you have something like this, A is to B, A is the first term, B is the what? Second term. And this can be expressed as over what? B. That means we have 2 is to what? 4. Can be expressed as what? 2 over what? 4. The same way we have equivalent fractions, we also have equivalent ratios. They're the same thing. Now, something like this, remember that 2 over 4 is equivalent to, hello? 2 over 4, do you think is equivalent to 1 over 2? It is right? Because if you multiply the numerator and the denominator by 2, it will still give you what? 2 over 4. So 2 over 4 and 1 over 2 are equivalent to what? Fractions. In the same way, 2 is to 4 and what? 1 is to what? Are equivalent ratios. Am I communicating? Because they have the same value. And if you divide this, their value is what? 0.5. True of us. The value is 0.5. Moving it to what? Half. Moving it to what? common fraction, decimal fraction is what? 2 over 4 will still give you what? 0.5. 1 over 2 will still give you what? 0.5. So this is an equivalent fraction. They are also equivalent what? Ratios. Remember I told you that all the rules that apply in what? Common fraction also apply in what? Ratios. Just note this point. I just want to do a kind of just introduction, then we'll start studying questions straight without wasting time. Okay? Now that's what ratio is all about. So a ratio is nothing but relative magnitude of two what? Quantities. Ratio of numbers or quantity. Ratio of two quantities is what? Can be defined as what? The relative magnitude of the what? The two what? Quantities. It's not an absolute value. That's why ratio does not have a unit. Ratio does not have a, do you know why? Because the two quantities must have the same unit before they can be expressed as what? As ratio. True or false? True or false? They should have the same what? Unit before they can be expressed as what? Ratio. So that the unit can do what? Cancel. Although when it comes to concentration, there are some concentration terms that are not in the same units. They're not actually what? Ratio. You leave it at that. Something like milligram over volume. You see milligram per volume. The only thing you can do is you hear something like you see something like weight in what? Volume. That's how they push the units. Percentage weight in what? Volume. Because milligram and mil are not of the same what? Unit. So they cannot cancel out. Or you see milligram per mil. You leave it like that. They cannot cancel what? Out. But when you talk of ratio, the two terms must be of the same what? Unit. That is actual ratio. Am I communicating? Now, with that at the back of our mind, let's look at proportion. What is proportion? Proportion is composed of two ratios. Hello? Proportion is composed of what? Two ratios. Proportion is composed of what? Two ratios. That means if a ratio has two terms, first and second term, that means proportion should have how many terms? 4 terms. The first term, second term, third term, and what? Fourth term. So that means if A is to B is a ratio and C is to D is also a what? A ratio. For these two ratios to come together to form a proportion, they must be equal. They must be what? Equal before they can come together to form a proportion. So you can define a proportion as an expression of equality of two what? Ratios. You can define a proportion as an expression of equality of two ratios. So if you want to express these two ratios now, if they are equal, they will form a what? Proportion. So you have something like this. A is to B. A is to B. C is to what? D. Or you can repeat it as this. A is to B. C, C is to what? D. Please, this thing is a sign of equality, but you don't say equal to. You don't say A is to B is equal to C is to D, even though the sign you are looking at here is equality. And the sign you are looking at here is double colon, right? You don't say A is to B, double colon, C is to D, or A is to B is to C is to D. Simply say A is to B as C is to what? D. That's how to express it. How to read it. A is to B as C is to what? D. That means the two ratios are equal. They are equivalent. Even though the magnitude of their terms may differ, but the value of the two ratios are what? Equal. So that means, do you think 2:4 and 1:2 can form a proportion? They can, because they have equal value. They are what? Equivalent. They are equal. So because they are equal, these two can form a what? Proportion. So 2:4 as 1:2 is a perfect proportion. 2:4 as 1:2 is a proportion, because 2:4 is equal in value with what? 1:2. Now, if you now want to put it in fraction form, if you are solving now, it becomes that 2 over what? 4 is equal to what? 1 over what? 2. Let us replace this with symbols or alphabets. That means we have A is to B as C is to what? D. That means A over B is equal to C over D. This is where the origin of your cross multiplication. So if you are looking for any of the terms, you can cross multiply and get the what? Find the terms. Let's assume you are looking for A. You can cross multiply. It becomes that A times what? D is equal to what? C times what? D. So if you are looking for A, you divide both sides by what? D. That means A is equal to what? C times D. This is B, right? Sorry. C times, what am I doing? B, yeah, B, good. Over what? B. So A is actually C times D over what? B. This is where the cross multiplication came from. A. What am I even doing? Wait, let me start afresh. So we have that A over B is equal to what? C over D. You cross multiply, right? So A times what is equal to what? C times what? Correct. So if you are looking for A, we divide both sides by what? D. Good. So A is equal to what? C times B over what? D. This is what we've been doing in our cross multiplication. This is where it came from proportion, okay? From what? Proportion. So any of the terms you are looking for, you can easily find the terms if you equate the two ratios. Now, if you are looking for B, it becomes what? If you are looking for B, it becomes what? It becomes what? A times what? Over what? Good. If you are looking for C, A times what? Over what? Over what? Over what? B. Good. If you are looking for D, it becomes what? B times what? Over what? So this is what proportion is all about. So we'll go to real, some examples, and we'll do one or two calculations to explain this. There's a question here. It says, if 3 tablets okay, look at the question on the board. It says, if how many milligrams should contain 12 tablets. So as you can see now, first of all, the thing you need to do to be able to identify the terms. Am I completing? Identify the terms. Are we together? So remember that the terms that are of the same unit should form a what? Ratio, right? Now, we have three tablets here, right? The unit of this tray is what? Tablet. Is there another unit that has tablet? So you do 3 tablets. Please don't forget your unit, okay? If you don't put your unit, it confuse you. 3 tablets over what? Over what? Over what? 12 tablets. Is equal to what? 9 what? Remember, this 3 tablet has business with what? Remember, it's not 12 that have business with this. Hope you know, because it's the one that contains what? This one. So this is the one that has business with this. So it should be the one here. Are we together? So 975 what? Over. We don't know we don't know this term, right? We can call it X or anything. So we follow all these things we've been doing here and do what? Cross multiply, right? So X now becomes what?
975 times
9 what?
75 times
Milligram times what? 12 tablets. That's not 12. 12 tablets over what? 3 what? Be coming down. Don't rush anything. Take your units seriously. Be first of all, cancel the units. You have tablet to do what? So we are left with what? Milligram. So we can now deal with the numbers, right? 3 divided 12 is what? 4. So 4 times 975 milligram is what? How much? How many? 3,900 what? Milligram. 3,900 what? Milligram. So in your answer, simply state, because the question says, how many milligrams should be contained in 12 tablets? Simply say 3,000, therefore 3,900 milligrams should be contained in what? Therefore 3,900 milligrams of aspirin, right? Should be contained in what? 12 tablets. Simple. 12 tablets. Simple. If you look at the other question that follows, if you look at the other question that follow, they are just changing the terms. Look at the question. Either you are finding a first term or second term, the same question, but you are finding different terms. Have you noticed that?
Yes.
Good. So I believe you can solve that. It's simple, right?
Yes.
It's very, very simple. But those that came now may look as if we are speaking ching chong chong. But with time they will understand. Now let's look at the second one. Especially China, those you know. She's so confused now. Oblo, Joe, one big question. But I will not answer because she came late. She didn't tell me where she went to, so I will not answer because she came late. You tell me where we are going to. You just disappear from class without informing me. What is it? How? Just look at how the question was asked. Because it was asked how many milligrams should be contained in 12 tablets, and you got 3,900 milligrams. Simply say, therefore, 3,900 milligrams of what? Aspirin should be contained in what? 12 tablets. Simple. Now let's look at let me write out the second one. They're just changing different terms. We are finding different terms. It's the same question. They are circulating. They're just changing the terms. To be able to explain that, now explain it with A and B. That's what they are doing. That they use figures to explain what I explain here with A and B. A, B, C, D, sorry. So let's look at number 2. Number 2, is it 2 or 3? Okay, question number 2 says, as you can see on the board, if 3 tablets contain 975 milligrams of aspirin, how many tablets should contain what? 3,900 milligrams. Now we are going to this first step is to do what? Set a proportion. We call it what? Setting up a what? Proportion. So let's set up a proportion here. Let's set up a what? A proportion. Look at this. Look at this. Now, if you look at, remember, as you are setting the proportion, a particular proportion in middle of two ratios, right? Now, the ratio should be the one in the same what? Unit, right? But the one in the same position as each of the ratio in the other side, in the other ratio, should be the one they have business with. Okay? It should be the one they have, the particular one they have business with. The particular term they have business. If you watch now, 3 tablet has business with what? 975, because it's 3 tablet that contain the 975. True or false? The same way 975 has business with what? 3 tablet. 975 has no business with 3,900. If you put it in the same place, you fail it. You commit pharmaceutical blunder. Now, let's set a proportion now. Let's consider the first ratio. The complete ratio we have here now is what? 375 milligram over what? Is it clear? So 375 what? 9 what? Sorry. 975 milligram over what? Is equal to what? 3 what? Hey. So I'm throwing my units away. 3 tablets over what? Are you aware? This must not be on top. Oh. Are you aware it can be like this? 3,900 watts over what? What matters is that the one that have business together, the link should be on the same position in this side. So this becomes what? Good, perfect. Over what? Perfect. Over what? Tablets. So either of them is correct. Once you position them what? Where? So you now find S by cross multiplication. And as we speak, Victoria is looking confused. Okay, not confused. Good. That's good. That's good. That's good. Is that what? The other is what? You cross multiply, right? This times this is equal to this times this. 3,900 times 3 tablets. You know, at any point in time, 3,900 always multiply what? 3 tablets. Even here, true of us. Go, you find S. So S is now equal to 3,900 milligram times 3 tablets over what? 975 milligram. Milligram, please, as you are doing your calculation, at any point, don't leave your unit and say, and N, I'll put unit. You will not put it. And you get 0. Don't leave it and say, at N, I'll put it. You're putting it at any step you're taking. It will help you to remember it, okay? Now, if you consider that, you have what? 12 what? Tablet, right? So the answer will now be 12 tablets contain what? 3,000 what? 900 milligram of what? Aspirin. Aspirin. 900 milligram of aspirin. Hey. All right, let's continue. So, as you can see, all the other questions is the same question. The two questions below is the same word question. They are just changing the terms. Which, if you know how to position these terms, you can solve them. It's simple. So I wouldn't want us to waste our time there. Okay, there's something else different. Let me look at something, another question that is somehow different. Let's look at another question that is somehow different. Even though it is the same principle, but they change the presentation is not the same thing. So let's look at this one. All right, let's look at question number 3. The question says, How are you? All right, let's look at this number. This the third question. Sorry, not one. The third question. It says, if 30 ml represents 1/6 of the volume of a prescription, how many milliliters will represent 1/4 of the volume? If 30 ml represents 1/6 of the volume of a prescription, how many milliliters will represent 1/4 of the what? Volume. Here again, we will set a proportion. First of all, you should be able to identify the different ratios that will make up the what? The proportion. The first ratio, look at this. Which of these things can form a complete, do you think will form a complete ratio here? 1/6. 1/6 and what? 1/6 and what? 1/4. They should have 1/6 of what? Volume of what? So it should actually be 1/6 V. True of us? True of us? Because we are talking about the volume of they didn't mention the what? Entire volume, right? You just 1/6 V over 1/what? Even though the V will cancel each other, right? But still put it. You show that you know what you are doing, okay? So it should actually, if you want to set a proportion now, the first ratio now that is complete, we know, is what? Is what? 1/6 what? V over what? V is equal to, which one has a relationship with 1/6 V? 30 ml, right? So we have 30 ml over what? We don't know it. So we cross multiply and find the value of what? X. If you understood everything we've been doing in common fraction, you can solve this. If you know the rules of your fraction, you can do what? Solve this. So X now becomes what? Cross multiply. Where is the, okay. You do what? You cross multiply. So this 1/6 V times X is now equal to what? 1/4 what? V times what? 30 ml. We're looking for what? X. So X is now equal to what? 1/4 V times 30 ml over what? 1/6 what? V. So here now V will definitely do what? Cancel. We are left with this. Remember the rule of our fraction. This is division. So this should become what? 1/6. 1/what? 4 times what? 30 ml over 1, right? Times what? 6 over what? This will come up, right? As we change this to what? Multiplication. 6 over what? 1. So what will happen now? 2 will go here, right? 15, right? Remember there's a volume ml here, right? Put it back. 2 remain here, right? 2 will go here. You have what? 3. 15 ml times 3 is what? 45 ml. So, in the answer is what? 45 ml. 45 ml will represent 1/4 of the what? Volume. I'm coming. I'm coming. 45 ml will do what? Can you tell me why? Can you? No, so 45 ml is now what? The 45 ml will represent 1/4 of the what? Volume. Good. Now there's a point I want to make here. You know, in our most of, I think I said something about that in the beginning of what when we're doing fractions. I told you that in FARMCAC, in practical real life, proper practical, it's preferable to use to numbers in what? Decimal fraction than in what? Common what? Fraction. The number is we in our calculations is actually what? Decimal what? Fraction and what? Instead of what? Common fraction. And this one is you can easily, if you're using a calculator, you can easily punch your calculator if it is in what? Decimal what? Hello, if it is in what? Decimal fraction. True of us? Good. True of us, you can easily punch your what calculator. So even if you punch, even if you divide, you converted this 1/6 to decimal, converted 1/4 to decimal. But what you get will be an approximate. Maybe 4.14, 4.99, whatever. Because of that 1/6 up there, it will render everything to be what? A continuous what? Number. So whether you solve it as decimal or solve it as common fraction, you get the same what? Answer. But I enjoy common fraction. It gives me no time for looking for calculator. Pia. You know. All right, so that's the answer. So the ratio and proportion that we statistics is finished too. Just this simple thing. What is it? What is it? There's something I want us to be doing. Hello, I keep saying this, but we still seem not to understand this. See, if you are in as much as me say I prefer speaking Igbo language, but in official gathering like this, try as much as possible to do what? Because one day you know where you see yourself, and you start speaking what they don't understand, and as you are speaking, you see yourselves speaking it. And yes, it's your right, it's your language, but people that you are speaking to, are they following you, or are you speaking to yourself? Because you appear in front of an audience for them to understand you, true of us. So you try to use a language they will understand, and it's a practice. Make it a point of duty that if you are in a gathering like this, official, try as much as possible to limit it. I am a pro Igbo. If I start speaking Igbo language, you won't hear any English. If I start to switch to English to Igbo language, you won't hear come. Is how I train myself. Am I communicating? So it's very important to do so, because some of us will end up not having a language. Even when you are not told to speak in Igbo, you start going back to the same English. And when asked to speak English, you are combining Igbo. Confusion everywhere. So speak one. Am I communicating? You speak what? One. It's very important. It's because of you. I said this. From South, you start saying ordinary. Speak one. If you don't want to use English, use Igbo complete. Can you do that? Then speak English now. If you can't Igbo complete, then speak English well. Okay.
This 1/6, this 1/6, the units 8
Continue. No, I just put on as something because if I don't say it, it will become part of you. That one day you see yourself speaking, you start mixing up. At the end, you end up not passing your message correctly. Okay, that's what I'm making. That's why if you've seen people speaking to, maybe if they want to use Igbo, they will say in Igbo language we say this, And after that, the person will still do what? Interpret it because he wants his or her what? Audience to do what? To understand what he's saying. I'm not against Igbo. It's my language. I'm proud of it. I also teach itself. But the point there is that know where the right language in every word gathering. Am I communicating? That's what I'm making. So, and this is the part of training we are in. We are in training. You learn it now. Unless you embarrass yourself outside one day. Or you continue.
Okay, sir. Do you need that 1/4 and 1/6 service? So you mean that that 1/6 is to that 1/4? And
Yes.
okay.
It's a ratio, yes.
So since this 1/6 is related to that 30 mil,
Yes.
so they should be in the same place.
Yeah, position. I said it's the same position. You don't carry this one and put here. You fail it. You will not get it. You fail it. Is it clear now? Is it clear now? So look at it as you just pointed out now. That this is one that is directly related to this one. True of us, because is this is 1/6. This one represents this. True of us. So they are related. So they should be in the same what? Position. But the one that will form the ratio is one that has the what? The same what? The same what? Unit. Is it clear? All right. So for what? Dot. Where is it? Where is it? Is to yes. Sorry, which one, please? Where is the dot here? Which one are you about? Which one? Okay. Bum. You were not there. You were not there. You went to enjoy yourself while we are here suffering ourselves. Now you want to come and learn what we learned. No. Unless they permit me, I'll talk about it.
Please, sir, permit me.
How much will you should pay? They say there's no time. And she went there, enjoyed herself, drank coke, gala, rested, and while we are here suffering ourselves. Now she want to come and learn what we learn. No way. Unless you give us one pen. Then we'll... All right. What it means, that is a sign of we say that two ratios form a proportion. Just as we have A is to B. Now, A is to B is a proportion, the first proportion. Then C is to D is another word, proportion. And for two proportions, if two proportions are equal, they will form if two ratios are equal, they will form what's called what? Proportion. So that it means A means that the two of them are equal. A is to B as C is to what? D. That's how to read it. You don't say A is to B, B, C is to D. Just simply say A is to D.
But it's not to solve any question.
That's what will be solving here is. That's what will be solving here is. That's what we will be solving here is. And we'll be solving the question. Okay. So let's see whether we can have see any other. Now, this thing you see here in question that has to do with proportion. That's what is called dimensional analysis. That's what is called what? Dimensional analysis. You can still solve question that has to do with proportion using dimensional what? Analysis. You did dimension in your secondary school, right? In your physics. You did dimension. Dimension has a lot to do with what? Units. Am I communicating? Units. The method of dimensional analysis is nothing but just alignment of the units. If you align the unit properly, they will cancel out and you get the answer you are what? Looking for. That one, there are some questions you will see You will set up to 3 proportion before you can get your final what? Answer. This one is just one proportion we set here. There are some questions you will see. You will set up to what? 3 proportions before you can get the final answer. But, but dimensional analysis method simply do what? Put everything in just one straight path. We call it unit path. One straight path. Just one straight. And go to your what? Answer without taking different steps. That's what dimensional analysis what? Helps us to do what? To do. Now, what we'll do is this. There's another question I want us to look at. Then that question, we'll solve it using our normal way with the certain proportion, right? Then after we'll solve it with what? Dimensional what? Analysis. So that's when we appreciate what I'm talking about. Now let's look at this question. Look at the question on the board. The question says, how many fluid ounces are there in 2.5 liters? How many fluid ounces are there in 2.5 liters? This question will set up to 2 proportions before we can solve this question. We will set up to 2 proportions. The first proportion we will set is the one that will take us from liter to milliliter. Then we'll set the second one that will take us from milliliter to fluid ounce. So you need to know the relationship between liters and what? Milliliters. Then you also should know the relationship between fluid ounce and liters. Actually, according to the American system, 1 fluid ounce is 29.75 mils. But for practical purposes, it's pegged at 30 mil. That 1 fluid ounce is what? 30 mil. But let's use the American system so we can see whether we can get the answer they got you, okay? Yes. But in my exam, I prefer using 30 mil, okay? Generally, I think there's some, I think British, it seems British is 30 or 28 mil. What does it now? To 9.75 mil. To 9.7. Now look at it now. Look at the question. Who can solve it for us? Who can do it? Who can do it? Oh, Emmanuel, come out. Come and solve this question. Also. Fast. Take. I solve it for us. Are you done? How about Ogia? So come. What did you do? What happened? Tell us now. Let's see what happened. The first one is what did you do? The first one.
1 milliliter is equals to 0.11.
Are you sure?
1,000.
This is tens of thousands. Look at the places of what you're writing. It's tens of thousands you wrote. I think that's where her issue came from. All right, let's solve it. Thank you. Sit down. Let's don't. We'll compare what we are doing now and what you did. Now let's look at this. Remember, I told you that this will lead to forming different proportions. I want to use our traditional setting of proportion method. Then after, we'll leave it and solve directly by dimensional analysis. We then compare the two of them and know the one that will give us what we are looking for. and the one that will be better and faster for us. So,
Okay, when are you finishing?
by 3.
Okay, and this guy is finishing by 3.
Yeah, I think so.
Okay, then will you supervise them to bring something from, because I want to go now from admin's office.
Miss office. Okay, I will inform them.
Because they reach them in the class.
Okay. Okay.
The freezer and the stabilizer.
Let me inform the boys. Let me just do this. If they don't
Electrons and what? Electrons and orbitals. See, brother.
Good afternoon. Please, the boys in this class. Immediately after this class, please, you meet up with the boys in that class so that we can get the freezer and the stabilizer from the admin's office. Don't go, the boys, don't go, please. So we can get the freezer, okay? All right, thank you.
Electrons and orbitals. Right.
All right, let's get started, please. Let's get started, please. Chinedu and Bethel. Immediately after this lecture, listen, please. Immediately after this lecture, we'll go up there in the admin's office with the facilities to get the freezer and the, what is it called, and the stabilizer from there. Am I communicating? We'll go together. All of us will go there. We'll get the our free freezer. All right, now let's continue. So how do we now? Okay, we are about to do before the principal came. What's going on here? What is it? Who? Hey, why? It's okay, it's okay. Now, the first proportion we'll set is, remember, actually, we have that 1 fluid ounce is 29 point what? 75 mil. But you were asked in what? Liters. So you do something about these liters. What is the relationship between liters and what? Before you can drive fluid ounce to liter, it must pass through what? Mil. And since 1 fluid ounce is equal to 29.75 mil, you also bring in another conversion factor that 1 liter is what? 1,000 mil. So you set up a proportion with this 1,000 mil first before you move to what? Am I communicating? Now, if you check now, here now, okay, so you set with this before you go. Now look at this. 1 fluid ounce is 29 point what? 75 mil. 75 mil. And 1 liter is, so we set first thing is that we set a proportion with 1 liter, 1,000 mil, and 29.75 mil. So we can find it in what? Liter, before we can move to this side. Now, if you now set the proportion now, you have what of 29.75 mil? What will be liter? We don't know, right? Now, we have the first term here, second term, third term, and what? Fourth term. This is in liter. So they can form a what? Ratio, right? So then 1 liter, even though you can do your cross multiplication. But I'm telling you the origin of this cross multiplication you've been doing. This is now 1 liter over what? X. True or false? Is equal to what? Over what? Male. So we can now cross multiply and find our what? X. That's what we've been doing here. They in your school, they just in your secondary school, they jump this step. Am I communicating? Yes. They jump this step within that, they jumped it and moved to what? Cross multiplication. That's what happened. That they tell you cross multiply. This is the step they jumped. It's after this step that you should do what? Cross multiply. Is it clear now? They're doing you can jump from here to here. Is it clear now? So this is step. Now let us now cross multiply. X times what? X times what? 1,000 ml is equal to what? 1 liter times what? Divide both sides by what? 1,000 ml. 1,000 what? Yeah. So this will cancel this. You are not left with what? X is equal to what? 1 liter times 29.75 ml over 1,000. So ml will do what? Cancel ml. So what is, you are left with liter. So how many liter? 0. What?
0.297.
What? Liter. You can leave it at 0.029. No. 0.03 ml, right? There's no issue with it. You can leave it at that, no problem. So, but let's just leave it at like this. This is what the answer in liter. You have gotten it in liter. So now we can now set the second proportion. With this thing you got now, you set a proportion with what? With this. Now we have what? Liter is this, sorry, here, right? We have what? You are asked how many fluid downs are there in what? 2.5 what? Liters. Can someone tell me a mistake we made here? Can someone tell me a mistake we made here? Can someone tell me if you made any mistake here at all, sir? Who? Tell me. I committed to what? Instead of what? Which one? I converted this one to what? Which one? This one to what? Right? The first stage should have been to convert this 2.5 to what? True or false? So I can set up a portion with this one, right? Right? True or false? This I got now is not wrong, but look at it now. It will make me to go and start. If I set up with this, it doesn't make sense. So where I want to set up is this. That will drive me to full dance. So I should convert the what? Liter to what? So since I have, this should be the last final step. So what actually should be here? 2.5 liter, right? Should move to what? Mils, right? This should move to what? Mils. And if just using this method, but this should move to what? Mils first. If I got it, if I get it in mil, I will now come here and set the what? Proportion. Because here now, if I move this one here, the terms of the proportion is not complete. Something is lacking. I have only liter and liter. What are the other fluid downs? Okay, let's just continue so you can appreciate what I'm doing. Now here, if you come here now, let's ignore this one first and see whether the step I took will give us a result. Now here we have that you are asked 2.5 liters and we have here 0.025 liters. If you now see now we have 2 liters. The other fluid downs is lacking. Unless we simply say that one fluid downs is actually what? Is what? True or false? We can still get it. It's okay. It's not bad. True or false? True or false? It's not, it's not bad. Hello? Calculation has no one step. Am I communicating? Good. What matters is this. To follow up. If you are lost, it's not the time to switch off and put your head in dismay. It's time to ask questions if you are what? Lost. That is the good best attitude towards learning. This thing now I did here, I wanted to first move this to what? Move this to what? It's okay. And I ask a question. What if that this thing I did is it wrong? Some say it's wrong. Some we are murmuring in the background that is correct. But actually, it's not wrong. Look at it. If 1 foot down is 29.75, I have moved this to what? Liter. So 1 foot down is also equal to what? 0.02575 liter. All here. Then what is this gloomy attitude? You don't understand question. You do what? You ask question. That is the best attitude to learning. Now, what I had in mind to do was to move this to what? Liter. But I first move this. But it's not wrong. It's still what? Correct. Because 1 foot down, if 1 foot down is this, that means 1 foot down is actually what? This. True of us. I cannot use this to set a proportion and get my answer. It's not true. Good. So this is 2.5 liter. This is what? 2.5 what? Liter. This is what I'm looking for. One foot down. Okay. Mils. Convert mils to liter. Convert 29.75 mils to liter. What's the answer? Convert. Remember that 1 liter is 100 mil. This study here now. Huh? That's the answer. True of us. So it's not what? Wrong. Whether I move this or this side is not what? Wrong. But what I had in mind doing was to move from here to here first. But I saw myself moving from here. So I stopped and checked. I asked you question whether it's correct. Some say it's correct, some were tired, some slept off, some switch off. But whatever you are doing, it's not what? Wrong, okay? Yes. Sometimes you may have it just so to say this, but it's a fact. There is let not talk too much. Let's continue. So this is 1 foot down is what? So this they are now in the same liter what? Liter. Foot down should also be what? Foot down. So you can say the what? Proportion. True of us. So 1 foot down over what? Is equal to what? 0. What? Liter over what? Liter. So find your x. Your x is now equal to what? 1 foot down times what? Obo is not 0. 2.5 liter over what? 0.02 what? What's the answer? Liter will cancel liter. So we are left with what? Foot downs. 84 point what? 033. Male. Sorry, foot downs. So whether you first converted this to male and fix it here and get the answer, or you move this to what? Liter and fix it is what? The same answer. But most important thing is that there are 2 steps you take. You change the what? The unit of the what? Liter. Male to liter or liter to male as the case may be. Before you can align with the what we have here in the what? Foot down. So either way is correct. Either way in a way. Either way is what? Correct. Now, have you seen all these long things we've been doing here since? Dimensional analysis, we just put it in what? In a straight path and you get your answer. But dimensional analysis can make or mar you if you're not careful. Because any mistake you make any mistake in the step, in that one straight line, you do what? You fail it. But if you know how to align your units well, you get your answer, okay? No, normal what? 84 points. You can leave it at 84 mil. What do you mean? Okay? You know this. There's no even way shape you can measure 84.0033 mil measuring. Is it possible? It's not possible. You just you can leave it at 84 mil. There's nothing wrong with it. Okay? Okay. Unless there's a specific DP you are told to leave it. That's when the issue comes. Okay? You ask a question now. No, just move 2.5 liter to mil, which you have done here. Even though you got 25,000 because you used 10,000. Just move to 2.5. Multiply 2.5 by 1,000. Multiply 2.5 by 1,000. Is 2.5 liter. So put it here. Put it here. 2,500 mil, right? Then wherever you see 2.5. Remember here is to 9.75. Here is what? Based on what you ask me now, here is what? To 9 point what? That means here is what? Male. Here is 2,500 what? They are now in the same units. You can multiply. Do 2,005 times divided by 29.75. What's the answer? A 3 point what? 33. Why are you getting different answers? If you use 30. Is it 30? Is it 30 you use in France? If you use 9.75, you get what? Can you a 3 point? Can you use? We are using 9.75. That also contributed to confusion most of you are having. Some are using 30. So I say, let's use this. But we know that in practical, this thing, the one that is practicable is what? 30 minutes. True of us. You can use 30 minutes. But for the purpose of what you are doing, use what? 9.75. Now let's solve this using dimensional analysis. Just one part. Answer while here. You don't need long thing. You don't need to start moving from one step to what? Step. Once you align your unit well, unit well, you will get your answer. See it here now. Okay, in our justice, Chobia Yafia. If we are not young, how many fly tea and I can only I want to know everything, even if it's 1 point. But it's okay. It's okay. It's okay. Are we done? Let's use dimensional analysis to find this. It just says threats. Once you can align the unit well, place the unit in a way that they can cancel out, you just get your answer straight. You don't need all this long step we've been talking about here. Now let's look at this. Now, in dimensional analysis, the first thing is to note the unit you are looking, the unit of the quantity you are looking for. Am I communicating? Now, from here, now we are looking for what? Frudans, right? Frudans, right? Good. So the frudans is what you are looking for. You rather the unit and put question mark. This is what you are looking for. Then you align what you are given and the conversion factors that can lead to what you are that can lead what you are giving. Now, list out the conversion factors, possible conversion factors here. The first one is that the first conversion factor is what? That 1 liter is what? True or false? Then the second conversion factor you need here is what? That 1 food ounce is what? Once you know this, you are good to go. If you know this, first of all, be able to identify the conversion factor you need in the path you want to create. Now, when you are done with this, the first thing that we hear is the unit you are giving, right? You are giving what? I mean the quantity you are giving, right? 2.5 what? Liter over 1. Then look at these conversion factors. Which of them has what? Liter. This one, right?
Yes.
Right? Is equal to, you multiply. You align this in such a way that liter can cancel what? Liter. You have what? 1,000 ml over what? Over what? 1 liter. Then you multiply. Go to the second conversion factor. There's a ml here. Which one has ml here? Huh? Check well. Which one? Which one? 29 point what? 75, right? Good. You now align it that male can cancel male. You have 1 foot down over what? 29 point what? You are good to go. Once you punch a calculator, you see the answer without wasting time. Let's go. Male will do what? Cancel male. Liter will do what? Cancel liter. There's no other unit here. The only unit remaining is what? Fudans, which you are looking for. Two of us. Then multiply all these things and divide and get the answer. Straight. It's 4 point what? Fudans. That's dimensional analysis. Just straight, get your answer. But if you don't know how to align it, you have issues. You carry the one that should be up and put below, and have issues. That's the only disadvantage of this. But if you know how to align it well, you get your answer straight. Without passing through all these steps, you move male to liter, you move liter to male. Maybe as you are moving as male by weight and use 10,000, at the end you commit blunder. Or maybe you forget that 1 liter should come first, and at the end you will be the wire levers here. Cancel over. Right, so that's what dimension analysis. Maybe if I see if there's another question here, if I solve with this one, I'll solve with that one. Then, or maybe I'll call somebody out. The person will solving with the other one. While I'll be solving with what? Dimension analysis. We know who will be faster. Is that what?
Okay, so.
Okay, you saw with the dimension analysis. Who is the person? Is that what? Okay. So now let's look at with this, like so now we are done with what? Ratio and proportion. We are placed with go to what? Variation. But let's see whether we can solve another question. Question that is more practical oriented. Even all these ones we solving are practical oriented because they are denominate what? Numbers. They are not just abstracts. They are denominate what? Numbers. Now let me see if I can see another question that we can solve. Okay, here. Eat now.
Oh, yeah.
All right, question 5 says, if an insulin injection contains 100 units of insulin in each meal, how many milliliters? How many milliliters? How many milliliters? Milliliters. Milliliter. I got it. How many milliliters should be injected to receive 40 units of insulin? If an insulin injection contains 100 units of insulin in each milliliter, how many milliliters should be injected to receive 40 units? Who can be solving the other side? Let me solve dimensional analysis. Who get mind? You come out. Come. You are pointing at somebody. Come. No, come. 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 I'll divide the body into two. You'll be solving using the you set up proportion. Why I solve using dimensional analysis? See, I be solving here. If you know what I taught you about setting proportion, okay, start here, Seth. Start here. Solution, start here. I'll write solution for you. Start here. Take marker. Take green marker. So be solving here. Why I solve using dimensional analysis? 1, 2, go. Be solving, no? Explain what you did. Explain what you did. No, explain. Do you know what you did? You explain your own. Me, I will explain my own. Explain your own. No. Can you hear her? Can you hear her? They cannot hear you.
1 millimeter is equal to 100 units. Then, okay, depending on what they gave you. So, 40 units over 1 times 1 millimeter over 100 units. Then cancel your units, cancel this unit.
If you don't get that, on my own. Can you not measure something? The same thing. Onya kita never. On your cam. Who will set the proportion as I taught you? Set the proportion. Just set it. Yeah, we all use dimensional analysis. That's in your set the proportion. Remember, if you want to set the proportion, remember it's simple. Now look at it. You know that okay, 1 ml is what? Contains what? 1 ml has to have business with what? Then what will have business with what? We don't know, we call it what? X. So 1 ml over what? Is a ratio, right? Is equal to what? 100 units over what? 40 what unit? You cross multiply, right? And if you cross multiply, S becomes what? 1 ml times what? Over what? 100 units. You need to do what? Cancel unit. 0 will cancel 0. This is 4 ml over 100, which is what? 0.4 what? Ml. Have you seen the tradition? Do you know why this is also straight? You just need one conversion. It's two of us. One proportion that you just set, right? That's why it's so simple like this. Now look at this dimension. Look at the dimensional analysis. Remember I said that the unit you are looking for should come out. You put unit and put what? Question mark. First of all, write out the conversion factor by the side. The conversion factor here now is just only one, right? 1 ml is equal to what? 100 units. Write it by the side. Now you write the unit you are looking for. We are still to find how many ml. So the unit is in what? Ml. Question mark. Now the first thing that will enter is the one you are giving. You are giving what? 40 what? Units. Look at 40 units. Now you now look at this conversion factor. Look at this 40 units. What can you do to this thing for you to cancel what? Units. You do what? You now put 1 ml on top, right? Over what? 100 ml. The unit will now cancel what? Units. 100 will divide what? 40. We have 0.4. Times 1 ml, you have what? 0.4 ml. That had it been there are up to, okay, let me look for a question that will have, that will take us to up to 2 steps. Then you see how beautiful dimensional analysis can be. If I get that one, please, I need someone that will not look at my own to come out and solve it. Not Chinaza. Chinaza is looking at my own. Okay, let me look at this one and see whether it adds up to 2 steps. So we look at the what? After this, we look at the variation: direct, inverse, joint, partial variation. Are you aware that your NEPA bill is calculated with partial variation? Are you aware? Are you aware? The bill consumed at home, that your bill is estimated bill they bring for you to pay is calculated using partial variation. Don't worry, when we get there, you understand. Because there's a fixed whatever and one that varies. True of us. Don't worry. By the time we introduce it, you understand it better. Now let me write out the next question so we can look at it. Victoria, since again our peace notes now. All right, let's look at this question number 6. It says an injection contains 3 milligrams of what? Medication in each milliliter. If a physician prescribes a dose of 0.5 milligram to be administered to a hospital patient 3 times daily, how many milliliters of injection will be required over a 5-day period? Actually, this question is a is a posology question. Posology talks about dosage. Posology talks about dosage. This question has to do with calculation of what? Doses, actually. Remember I told you that proportion, ratio and proportion constitute up to 90% or more of the calculation you are going to do. So it enters into different topics. Different topics, you must apply ratio and what? Proportion. That's why you should not joke with ratio. It is the bedrock of most of the things you do in calculation. You see, ratio and proportion and measurement. If you know ratio and proportion well and know your measurement well, you've known up to 90% of what there's no way you cannot get from calc A. It's not possible. If you know your measurement well and know your dosage, and know your ratio and proportion very well, there's no way you cannot get A in farm calc. Even if you don't know any other topic, because there's a question if they give you this, even if you not read dosing as a topic, and they give you this thing as a question, once you know your proportion, you can answer it. Once you know your proportion and your what? Unit, you answer it. Your unit will help you to know your measurement. Pharmaceutical measurement will help you to know the relationship between different what? Units. True of us. Now, to help you to handle your conversion from one unit to what? Another unit. And you know your proportion will help you to actually do the main calculation. But this is even the first one we did about insulin is still about what? Dosing. True of us. That's why I said this at the beginning of this topic, that if you know your proportion very well, you are good to go. So don't joke with this, what you are doing now. It's not a time to be jumping up and down, going out and coming in. It's time to actually participate actively in what you are doing. I pity those that are not in this class. When they come back, it will look as if we are speaking Chang Cheng Kong. They won't understand what we are doing. They won't understand what is happening. It will look as if someone that traveled for 20 years and came back, or the person doesn't know his homeland again. You'll be confused. I just pity them. Don't you know why they're not in this class? Okay, now let's continue. Okay, look at this question. Hey, I said that someone who is solving in what? Normal, someone, and the blessing will set up proportion for us. What is it? No, you will do. You'll not be looking. Come and do. Are you afraid? Chinaya, come. Mora, hi. Mora, hi. Come, fast. You solving this side. Me, I'll be doing Kedafia dimensional analysis. Let me give you more space, because this you will set up different proportions before you can solve this thing. Let me do my dimensional analysis here. Just sit this place. Take this side. Don't look at my own. Take this side. Why I try to face here? So let's solve it with what? Dimensional analysis. What you are doing your own after you explain what you did. Okay, I think I have set the dimension. See what happened. I started, I said that the last unit you are giving should come first, okay? But I went and started with male. On going down here, I was hooked on the way. So what happened is this. We are trying to find required over what? 5 period what? 5-day period. So that 5 days should come what? First, okay? That 5 days should come what? First of all, I listed all the, what is it called? All the conversion factors. The first conversion factor here is what? That one male is what? 3 milligram. Second conversion factor is once a day, one time is what? Then the next one is that one day is how many times? 3 times. Now, if you start from the 5 day, the days, 5 day, right? 5 day, you align the 5 days there, you align this 1 day and 3 times. So day can cancel what? Day. If earlier now we have that 3 times over what? 1 day. Now, in that day, we have that one time is what? 0.5 milligram. Now, the idea, the target now is to cancel this time. So you now turn this one. You have what? 0.5 milligram over what? 1 time. Now, time has been taken care of. Now, milligram, what can cancel milligram? You have 1 mil is 3 milligram. You now invert it that you have 1 mil over what? Milligram. So that milligram can cancel milligram. So if you go now, they will do what? Cancel day. My concern is not in the figure, it's the units. They must align. Time will cancel what? Time. Milligram will cancel what? You are left with what? May you are looking for. Once you are there, just punch your calculator, you get 2.5 mil. Just do 5 times 0.5. Of course, now 3, just multiply the numbers. By virtue of getting the unit, I've gotten the answer. Remember, dimensional analysis, you focus on the what? The units. Align the unit properly. Don't look at the number. You're not being able with the what? Numbers. Align their unit. Once the unit can cancel out, you get the answer. 2.5 what? Mil. Good. Because 5 times 3 times 0.5 times 1 divided by 3 is what? 2.5 what? Mil. So the answer is what? This is what dimensional analysis talks about. Once you can identify your, what is it called? Your conversion factors. List all the conversion factors. See, if I did this thing using that normal proportion, I will set 3 proportion before I can get to this level. She set 3 proportions here, but she was jumping the steps. That place you are saying she did if in a day you have 100 mil, 3 days. This is our proportion, different proportions. Am I communicating? But if you can align them properly in a straight line, you get the answer. Once the unit can cancel, you are good to go. So once look at the question, say in 5-day period. So 5 days should come first. Then you start aligning other factors until you get your final answer. So the answer is what? 2.5 mil. This is how I solve questions. I don't give up. You keep looking at it. There must be a way. If you develop that mindset, there's nothing you cannot achieve in this life. Not just about academics. In all your life. I was here somewhere busy carrying their bag, jumping up and down, playing. Instead of sitting there to look how I can reason it out and get an answer. All right, I don't know if you have any question.
Yes.
Okay, ask. Understand what?
I took this 0.5 3 times this.
What I'm saying now, once that 3 times daily, one time, that is once is how many milligram? Once, how many? You said if you take 0.5 milligram 3 times daily, once it's how many milligram? Once, just once, one time is how many milligram? Answer me. Once is how many milligram you take? If you're asked to take 0.5 milligram 3 times, right? Once is how many milligram? No, you are talking about a male. I mean a milligram. 0.5 milligram. One time is what? 0.5 milligram. Don't you understand this? This is simple English language now. Okay. No, you confuse that anymore. He said that you only prescribe a dose. A dose is what? How many milligram? How many milligram is a dose here?
A dose of 0.5.
And you are taking three times a day. So once a dose is how many milligram? All I be here one time, or is it good that if I put those in, that I run away from those because we are not talking about dosage calculation. If you watch, I try to avoid anything dose. And if I go there, you're confused. That's why I remove by right. It should be one dose. But I don't mention we have not treated what dose. That's why I run away from it. But I just said one time. Just once you take it is what? Once you take it, how many did you take? How many milligrams? So one time is what? 0.5 milligram. Then a day is how many times? This is a different conversion factors. You cannot align them here. So for 5 days is what you're looking for, right? That's 5 days over 1. What can you, from this conversion factor, what can you align to cancel day?
1 day.
You bring 1 day on top, below, right? So you can cancel it, right? It's 3 times over what? Because in a day is how many times? So 3 times should come up over 1 day. So they will cancel what? Day. Now, what is even here is what? Time. What can you do here to cancel time? You align 0.5 milligram and what? Time. And for you to cancel, time must come below. True of us. So you have your what? 0.5 milligram over what? Time. Time will cancel time. True of us. You are destroying the units. That's your target. Now, how can you destroy this milligram? Look at all. What can you destroy it with? 1 million is what? 3 milligram. Align it so that the milligram can do what? Cancel what? Milligram. You do it at this. We have what? 1 million over what? 3 milligram. So with this now, milligram will cancel what? Milligram. What will remain is the unit you are looking for, which is what? Male. Because you put it as question mark here. That's the unit you are looking for, male. So you can now multiply everything and divide the numbers. You must get the answer. That's why it's called dimensional analysis. Your focus is on the units. Align them properly. Before we started dimension, I asked you did dimension in your physics. You said yes. I don't know whether you say yes or no. But if you know dimension, you focus is on units. Once you hear dimension, it's all about what? Units. And you have to align them well so they can cancel out. And when they cancel out, these numbers are just abstract numbers. What made them what they are is the what? Units. That's why unit is so powerful in whatever you are doing. Once you know your unit well, you are good to go. Any other question? All right, in the absence of any question, we'll stop here. Any question? We'll stop here. Thank you very much for your attention.
Thank you.
God bless you.